be studying the titration of sulfuric acid to determine the concentration of a specific sample of sulfuric acid. We have a few different words that will be used in this laboratory and in this discussion. First is a standard solution. Standard solution is a solution containing a known amount of solute. In this case, it's going to be the dissolved substance sodium hydroxide. Titration is the process that we're using. It's careful measurement of a volume of a standard solution that is required to react with a known volume or mass of the substance being analyzed. In this case, a volume of sulfuric acid. The indicator, it's a substance that changes color when the titration is complete. And then for this lab, it's going to be phenolphthalein, which changes from clear to pink. And the end point or equivalence point, the point at which the titration is complete. This is signaled by a color change with the indicator. Here's the reaction that we're going to be looking at this week, the neutralization reaction between sulfuric acid and sodium hydroxide. Since sodium hydroxide contains 2 protons, it requires 2 equivalents of sodium hydroxide base in order to be completely neutralized. In the neutralization reaction, we get 1 equivalent of sodium sulfate dissolved in the solution and 2 moles of water. The process of the process that happens during this reaction is referred to as neutralization. And here's our pH indicator for this particular reaction. It's known as phenolphthalein. Phenolphthalein looks like this when it is at an acidic or slightly basic pH. The molecule looks like this, and the solution is totally clear. It looks like water. However, if we go above 8.2 to more basic pH, it turns to either a pink or fuchsia color. So in our reaction, the moment when we went essentially about 1 drop past the equivalence point, we'll get a rapid color change from colorless to fuchsia when we've added just a tiny excess of sodium hydroxide. All right, let's look at the start of a titration reaction. At the beginning, we're going to have excess sulfuric acid, and we're going to be adding in sodium hydroxide. And so at the beginning of the reaction, at the start of the titration, there's more than enough sulfuric acid to react with all the sodium hydroxide. The sodium hydroxide gets rapidly used up, and the solution, the phenolphthalein, stays colorless. However, when we get near the end of the titration, where we have an extremely slight excess of sodium hydroxide, then the phenolphthalein changes immediately to pink. It's amazing how quickly this can happen. So here's the overall reaction, what it looks like at the neutralization point. We're going to have a known volume of H2SO4, and you will, at the neutralization point, have added exactly 2 molar equivalents of sodium hydroxide. The sodium hydroxide, you will know the molarity, will be provided for you, and you will have measured the volume. So at the moment of complete neutralization, the moles of H2SO4 will be equal to half the moles of sodium hydroxide, because it requires 2 moles of sodium hydroxide to neutralize every 1 mole of sulfuric acid. Let's talk a bit about how to read the burette again. So read your burette at the beginning of the titration to the nearest 0.02. This does not have to be exactly at 0.00. It's a waste of time to try to get it exactly there. Anywhere between, say, 0 and 1, anywhere in there is a good point because you're going to read it. So it doesn't have to be exactly 0. So here in this example, it's 0.48 mLs. So close to half of 1 ml. And that's going to be our initial volume. And a sheet of paper behind this makes it much easier. It gives better contrast. It makes it easier to read the exact location of the meniscus so that we can figure out this is exactly 0.48 mLs. As the titration goes on, a second piece of paper is useful to go underneath the flask. It's easier to see the slight pink, which is what you're looking for, as the phenolphthalein goes from clear to pink. So a sheet of paper underneath the flask is very helpful. What this reaction will look like is initially you'll have drops hit the solution. The point at which the drop hits the solution will go pink. You will swirl, it will disappear. And then as the titration goes on, the pink will linger for longer and longer and disappear until finally it lingers for 10 or 15 seconds as a slight pink, and that would be a perfect endpoint. Okay, and this should say sulfuric acid here. At the end of the titration, you will have a lingering pink color. So this is getting really close to the end, and you'll have a lingering slight pink at the end of the titration, a very faint pink color. And then you'll read your burette a second time to the nearest 0.02. You're going to estimate as closely as you can to 2 decimal places. And you'll estimate the final volume, and we've estimated this to be 23.90 mLs. And then we can do some math here. The volume of sodium hydroxide solution dispensed is the final volume of 23.90 minus the initial volume of 0.48 to give us 23.42 mLs dispensed. Once you've done this, you're going to do 3 trials total. You will want to, after you've measured your final volume, fill this up again close to 0, not past 0, but somewhere around 0, and start this trial over. All right, in lab today, rinse out the volumetric pipette with 2 times distilled water and then 2 times sulfuric acid. Rinse out the burette with 2 times distilled water and then 2 times 10 mLs of sodium hydroxide. Use the volumetric pipette to dispense the 25 mLs of sulfuric acid into an Erlenmeyer flask, and you'll add 40 mLs of distilled water from a graduated cylinder. Add 3 drops of phenolphthalein indicator to the sulfuric acid. Fill the burette with the sodium hydroxide solution. Again, near the top is good, but it does not need to be exactly 0.00. Record the starting volume to the closest 0.02 mLs. Slowly add sodium hydroxide solution while swirling the flask to aid in mixing. When the sodium hydroxide hits the H2SO4, that part of the solution will turn pink. Swirling will return to clearness. As the sodium hydroxide is added, the pink color will require more and more time to dissipate. When the color becomes very slow to dissipate, begin adding the sodium hydroxide solution dropwise. When a faint pink color persists, you are done. Record the final volume. The volume of sodium hydroxide solution used is equal to the final volume minus the initial volume. And here's a few more tips and tricks for this lab. Each will do 3 trials as long as sodium hydroxide volumes between the trials agree to within half of a milliliter. In step 2, pour out only about 50 mLs of sulfuric acid into a clean, dry, labeled beaker, and don't pipette directly from the stock bottles. In step 13, pour out only about 160 mLs of sodium hydroxide into a clean and dry 250 flask, and make sure to stopper it. Sodium hydroxide solutions react with carbon dioxide in the air. Estimate burette volumes to the nearest 0.02 mLs, and this is worth 2 points when we're grading your lab reports. Make sure to use the calculations on page 96 to look at that when you're doing the calculations. Want to be very safe today. We have acids and bases you want to handle with care, and you want to alert us to any spills. As far as waste disposal, all liquid waste can go down the drain with a water flush. Clean up. Rinse the pipette and burette before returning to the bins. And then finally, here can help if you run into any problems during this lab, any very strange problems. So if the solution is immediately pink when you add the indicator, or the solution never turns pink, then the wrong solutions have been added to the flask, the burette, or both. Occasionally a group will mistakenly load the flask and burette backwards. So they'll put the acid in the burette and the base in the flask, which is backwards, or mistakenly load water into either the flask or burette. And litmus paper can be your friend here. It can be used to confirm the identity of the solutions. So as far as litmus paper will always be red when exposed to acid. So we'll take blue litmus paper. If we expose it to acid and it turns red, that indicates that we're dealing with an acid. If we take red litmus paper and expose it to base, it will turn blue. So red litmus paper turning blue indicates a base, or blue litmus paper turning red indicates an acid. If we take red litmus paper and expose it to acid, we get no change because the exposure to the acid makes it red. It's already red. We don't see a change. Same deal with the base. If we take the blue litmus paper and add base, we don't see a change. So one more time. To test for an acid, blue litmus paper should turn red, and to test for a base, red litmus paper should turn blue.